Hello grade 7, it's me Teacher Jo, and I am back for another video lesson about technical drawing. In this lesson, you will learn what is an oblique drawing and how it is made. But before we start with the discussion, make sure that your eyes are ready to see, your ears are ready to listen, and your mind is ready for a new knowledge. Without further ado, let's begin. What is an oblique drawing? It is a type of pictorial drawing where one of its surface is parallel to the projection plane. Like isometric drawing, it also have three axes: vertical axis, horizontal axis, and the receding axis, where it can be projected from 30 degrees to 60 degrees. Using the given picture, can you answer the following questions? Which of the two drawings do you think is an oblique drawing? Correct. Drawing B is the oblique drawing. And what do you call the other drawing? That's right. It is an isometric drawing. Now, let's try to differentiate oblique from isometric. As I have said earlier, in an oblique projection, one of its surface is parallel to the plane of projection. It means it's like you are looking directly to the object's surface, so just like this. While in an isometric projection, its surfaces are tilted at a specific angle. Its sides is projected at 30 degrees. In this example, we can clearly see the difference, right? Both front views are highlighted with color red to emphasize the difference on how they are projected or drawn. There are two types of oblique drawing. The types of oblique drawing are: Number 1, Cavalier oblique. It is obtained when the angle between oblique projectors and the plane of projection is 45 degrees and the rear projections or depth are true to size. Second, we have Cabinet oblique. It is an oblique projection where the length of the lines projecting backwards, or the depth, is half of its total length. Let's compare the two types of oblique drawing using the given picture. Both drawings have full height and full width, which means if a certain dimension is given, you will draw it in its true size. But you will notice that they differ in depth, right? In a Cavalier oblique, the dimension would be in full depth, while in a Cabinet oblique, the dimension would be half of its true length. Also, in a Cavalier oblique, the shape of the object seems to be distorted or deformed, while Cabinet oblique appears to be normal in terms of its overall appearance. For example, both have the same height, which is 2 centimeters. Both also have the same width, which is 2 centimeters as well, but their depth will be different. In a Cavalier oblique, full depth or the true dimension will be used, which is 4 centimeters, while in a Cabinet oblique, the given dimension will be halved, which means 4 centimeters will be 2 centimeters in a oblique drawing, because 2 is half of the 4 centimeters in an oblique drawing. Now, do you understand the concept that I am giving you? Let me repeat. The height and width of both drawings are drawn at its full size or true length, while their depth differ. In a Cavalier oblique, the dimension used is the true length, while on the Cabinet oblique, the depth will be halved. Let me first ask you questions to see if you really understand what I have discussed to you. Number 1. If the depth of the cavalier oblique is 10 centimeters, in a cabinet oblique it will be? What is the answer? Correct. Since cavalier oblique is drawn at its full depth, which is 10 centimeters, in a cabinet oblique it will be halved, which means that the depth in cabinet oblique will be 5 centimeters. Number 2. If the height of the cavalier oblique is 5 centimeters, the height of cabinet oblique drawing is? Correct. So the height is the same with the cavalier oblique. Number 3. If the width of the cavalier oblique's front view is 3 centimeters, in a cabinet oblique it is? Correct. It is also 3 centimeters since both width is drawn at a full size. Number 4. If the depth in a cabinet drawing is 4.5 centimeters, in a cavalier drawing it will be? Great! The depth in the cavalier drawing will be 9. Since cabinet drawing is drawn at 4.5 centimeters, it means that you will have to multiply it by 2 to get the size of the cavalier drawing. Number 5. The angle of inclination in an oblique drawing may range from 30 to? Nice! From 30 to 60 degrees. So great! I hope you are now really ready to begin. Now that I have given you the background information about oblique drawing, let's begin constructing them by following the steps that I prepared for you. But first and foremost, we should always check if all drafting materials are ready for use. So in this activity, you will need
a T-square, ruler, the 45 degrees triangle, pencil, and eraser. So before you begin, make sure that your paper or your drawing paper is securely attached to your drawing table.
Earlier in this video, I have mentioned that there are 3 axes in an oblique drawing. Can you still remember? If yes, can you enumerate the 3 axes that I have mentioned? Very good. The 3 axes in an oblique drawing is called the vertical axis, horizontal axis, and the receding axis. So just like in an isometric drawing, these 3 axes will be your foundation in creating the main shape of the object. So let us use this drawing as a reference in creating the oblique drawing. This is a cube with a measurement of 3 centimeters. The steps that I will give you on this activity is slightly the same with the steps that I have given you on the lesson about isometric drawing. The end part will be the only step that is different. Are you ready? For operation sheet number 2.1,
for the step number 1, get the height, width, and depth of the given object, then project the 3 axes. So since we have a cube measuring 3 centimeters, it means that the height, depth, and width will be the same. So let's create the vertical axis, the horizontal axis, and then the receding axis. So I will create two sets of drawing here for the cavalier on the left side and then cabinet drawing on the right side. And then the receding axis. Okay, so now I have created the three axes. And then it says here that you have to get the height, width, and depth, which is 3 centimeters. So let's just mark a distance from their intersection. So remember that in a cavalier oblique drawing, the depth will be drawn in full size. While in cabinet drawing, the depth will be half of its true dimension. So we have the true dimension of the width on the cabinet drawing, and then the true height, then the depth will be half of its true length. So since we have 3 centimeters, if we divided it by 2, or in its half, it will be 1.5 centimeter. So there we have 1.5. Now that we have marked all the dimensions, let us proceed to the next step. For the step number 2, using the 3 axes, create the base form of the given object. So when we say base form, it is the origin shape of the object that we are going to create. So we just have to project from the points that we have created. So in our cavalier drawing, we will be projecting this line. Okay, so let's just create or project all the vertical lines. And in a cabinet drawing, project. Okay, so next, after projecting the vertical lines, let us now create the horizontal line using our T-square. So let's erase this part. So now we are done projecting the horizontal line. The next line that we will be projecting is the receding line. So we are going to use this 45 degrees triangle to project all the receding lines or the diagonal lines. Okay, so now we will notice that there is still a missing edge on this drawing. So the edge on the top view is still missing. So from the intersections of these two lines, we will be creating a horizontal line. We will also apply the same procedure on the cabinet. So from this intersection, we just have to create a horizontal line. Okay, so now we are done with creating the base form of the object. But since the given object is a cube, we will now finalize it by darkening, or we have to outline the edges of the object. So using our ruler or any straight edge material, ruler, T-square, triangle, it's okay. So this is our Cavalier oblique drawing. And then let's outline the cabinet drawing. There, we have the Cavalier and the cabinet oblique drawing. So after finishing the drawing, of course, you have to label it or indicate its name. So we have the Cavalier, and then the cabinet oblique. And then after indicating the name or writing the name of the type of brick drawing that you created, the next step would be indicating its dimension. So if you are required to put the dimension, you will have to draw it. So for example, you will have to create the dimension of the height. So from this point to this, so we will be creating 3 centimeters. We will write 3 centimeters. So 3.0. And then the width is also 3 centimeters. And then the depth would be also indicated. And then for the cabinet drawing, we'll just do the same. So these are the extension lines, and then this is the dimension line, and also this one. So here is the question regarding this measurement. So if the measurement of the dimension given in a cabinet drawing is gathered from the cavalier oblique, so we will be writing 3 cm, not 1.5 cm, since we have to indicate the true size. Even though the representation is half, we still have to indicate the true size or the true dimension of the object. Centimeters. So there, we have completely constructed, created, drawn a cavalier oblique and cabinet oblique.
Now, what can you say about the first activity that you created? Was it easy or hard? For the next activity, we will be trying to create the oblique drawing of this orthographic view, which is a bit challenging for you. Are you ready? For this step number 1, we have to get the height, width, and depth of the object, then project the 3 axes. So since we have a different feature in this activity, we will have to find where is the height, width, and then the depth. So the height would be this one, this is the width, and then 4 cm is the depth.
So just like what we did on the first activity, so we will be applying the same steps. So first we have to create the horizontal axis. So now we have the horizontal axis. The next step would be creating the vertical axis. Now I have the vertical axis for the cavalier, and then the vertical axis for the cabinet drawing. After the vertical axis, we will be creating the preceding axis. So for the cavalier oblique drawing, so the dimension is 4 cm, right? Just always check the dimension that is given. So we are done creating the 3 axes. The next thing that we are going to do is to mark the distances or the dimension that is indicated on the orthographic drawing. So for the width, we have 3 centimeters. So 3 centimeters in the cavalier drawing, and then 3 centimeters for the cabinet drawing. For the height, we have 3 centimeters also. So 3 and then 3. For the depth, we have 4 centimeters. Okay, so 4 for the cavalier drawing, we will be marking 4 centimeter, and for the cavalier, we will be marking 2 centimeter. Always remember that the depth of the cabinet drawing is half of the original size. So using the 3 axes that we have created, together with its dimensions that is marked on each axis, we will be creating the base form of the given object. And to do this, we will just have to project. We will be projecting all the vertical axes or the vertical lines from both the cabinet and cavalier. So there, we have projected the vertical lines or the vertical edges of the drawing. The next would be projecting all the horizontal edges. So after projecting the horizontal edge, we will now create the receding axis or the vertical, or the diagonal edge. So from the intersections, we will be projecting a diagonal edge. And then this one. And then again, there is a missing edge on this part, on the top view. So we will create the horizontal line from this intersection and then from this. So now we are done creating the base form of the object in a cavalier oblique and cabinet oblique.
For the step number 3, analyze the surface of each views. Create first the front view, then do the remaining views. So this is your front view, and you should be able to create this on your oblique drawing. Take a look at the front view. You will notice that it doesn't have any dimension that is indicated to it. But don't be confused or don't worry, because you just have to look at the parallel edge of each side or the edges on the front view. So for example, the edge on the upper part of the front view will be the same with the dimension of the edge on the top view, which is 1.5 centimeter. The same applies with on what's on the right side view.
The surface of the front view is like letter L, right? So it's like letter L. And the measurement or the dimension is 1.5 on the top view, and then 1.5 of the width, and then 1.5 of the height on the right side. So let us just measure 1.5 and then 1.5 here. So you will do the same on the cabinet drawing. After marking the dimensions, we are now ready to project the lines. So for this point or mark that we created here, let us project a horizontal line. Okay. And then from the mark that we have created on this edge, we will project it vertically. So there, we already have the surface of the front view. But we cannot still outline it because the feature of the other surfaces is still a bit confusing, or you might get confused if you outline it early. So the next would be creating the top view. So from the intersection of this point, we will be projecting a line. So just project, and then from in this cabinet drawing, we will also project. And then we will also project this from this point. And then this one. What else should we project? Okay, so we still have this intersection. Okay, so it's already projected. And then this one. Okay, there. So what else should we project? What do you think? So we have to project this intersection here and then here. Just project it vertically or downward. And then let us analyze the feature of the top view and the right side view. So since I guess there is an error in the drawing that I have presented, but anyway, let's follow what is on the drawing. So on the depth of the object is divided into two. So in the cavalier drawing, we will be marking 2 cm on this part, on this edge, and then 2 cm on this edge. So for the cabinet drawing, since it is already halved, we will divide it into 2. So we have 2 cm divided by 2 is 1. And then mark a distance of 1 cm here. So after creating the distances that we have marked, so we'll have to project again. So let's project the horizontal lines, and then the horizontal line here, and then on this part, and then on this part. So after that, we have to project a vertical line from these intersections. So now we are done with the views or the 3D object in a oblique form. So the last step would be to draw the outline or the edges of the object. So let's first do this cavalier drawing. you just have to analyze the shape of the object. And whenever you are creating any three-dimensional drawings, I don't know, it's just based on my own experience, and it is the usual thing that I do, is I always start creating the front view, because I think front view is the foundation, or it is where all the lines are being projected. Which means that if you are able to determine or to analyze or to see the shape of the front view, then it will be easy for you to create the rest of the views. And really, it requires a skill in visualization. But it doesn't mean that if you don't have this skill, you won't be able to create a 3D drawing. You just have to practice. So there. So this should be the original form of the drawing, but since on the orthographic drawing we have a line here, so we will disregard that and then the line here, so it is an error. Gladly I was able to see it. So the last thing that we are going to do is to write the name of the drawing. So we have Cavalier Oblique. And then the cabinet oblique. So that's it. We are done creating the oblique drawing of the given orthographic view.
I hope that you learned something today, and I would like to thank you for watching this video and have a happy learning. Bye!